Hello, good morning to all sa aking mga avid listeners and followers. So today we will have our new lesson, lesson 6. So this is the last topic for midterm. We have about geotechnical engineering. Okay, basics of geotechnical engineering. So for desired learning outcomes, you have the knowledge of the scope of geotechnical engineering in the field of civil engineering as a specific career. Okay. So technically, geotechnical engineering is the broader term for soil mechanics. Okay, so it's defined as that base of civil engineering that deals with the state of rest or motion of soil bodies under the action of force systems. So the application of civil engineering technology to some aspect of the earth. So a brief history. So sa unang panahon daw, constructing dikes and levees out of the soils found in river flood plains started during ancient Egyptians, Babylonians, and Chinese and Indians. Then the Aztec constructed temples and cities on the very poor soils in the Valley of Mexico, long before the Spaniards arrived. European architects and builders during the Middle Ages learned about the problems of settlements, of cathedrals, and large buildings. So one notable example is the Leaning Tower of Pisa. If you're familiar mo sa Leaning Tower of Pisa. Scandinavian used timber piles to support houses and warp structures under salt place. But during the mid-1700s, the design of foundations and construction involving soil and rock was developed. So doon na nagsimula mga design ng mga foundations sa constructions. Okay. Si Colum, most famous geotechnical engineer, interested in problems of earth pressures against retaining wall. So actually, dili pa siya ginatawag na geotechnical engineer. Then here comes Mr. Colin, which concerned is a study concerned with failure in clay slopes, as well as measurement of shear strengths in clays. Then we have Mr. Darcy, established law for the flow of water through sands. So usually sila, ma-encounter nyo sila sa inyong soil mechanics ng mga subjects. Okay. Then we have Rankine. He developed the method for estimating the earth pressure against retaining walls. Okay. And then we have Mr. Gregory. He utilized horizontal subdrains and compacted earth uh, fill buttresses to stabilize railroad cut slopes. Okay. And during the 1914 and 1922, so Mr. Atterberg defined the consistency limits for clays. Then the Geotechnical Commission of the Swedish State Railway, the first to use the word geotechnical. And year 1925, Professor Karl Terzaghi, an Austrian known as father of soil mechanics, published first modern textbooks on soil mechanics. So yun siya yung pinakaunang nakapag-publish ng libro about soil mechanics. So geotechnical engineering contains soil mechanics, which is about soil properties and behavior. This is the branch of geotechnical engineering concerned with the engineering mechanics and properties of soil. Okay, may subject na soil mechanics sa higher years ninyo. And then soil dynamics, dynamic properties of soils, earthquake engineering, machine foundation. Usually yung say dynamics of movement. So galaw ng lupa. Okay, paggalaw or then we have the foundation engineering. There are two types, the deep and the shallow foundation. So it applies geology, soil mechanics, rock mechanics, and structural engineering to the design and construction of foundations for civil engineering and other structures. So, mayroon din kayong subject na foundation engineering in your higher years. So, this topic will be discussed to you in details. Okay, we have the pavement engineering, flexible and rigid pavement. I think kasama rin siya sa transportation engineering siguro na subject. And then we have the rock mechanics, rock stability and tunneling. So it's concerned with engineering, mechanics, and properties of rocks. And the geosynthetics is about soil improvement, on how you will improve the soil condition na hindi siya basta-basta mag-fail or wash out. Okay? So what do geotechnical engineers do? So we have number one, it design foundations, design retaining walls, mga dams, etc. It evaluates the slope stability of the ground, estimate settlement. Settlement means paglubog ng ground or lupa. Yun yung pinag-aaralan dyan. Then we have the evaluate groundwater flow. So it's about the tubig naman sa ilalim ng lupa. And then it evaluate hazards, the earthquake, landslide, and liquefaction. So it all related sa soil. Okay, so napaka-broad. Dami niyang uh, scope. So usually ang mga geotechnical engineers, nag-work sila sa mining industry, sa mga planta ng dam, sa mga planta, sa PBOX, sa pag-asa, sa DOST, yun. Yun yung mostly na pinupuntahan nila. Kung saan sila na-hire. Usually pag geotechnical engineers ka, syempre ano yan specialize civil engineering, so you need to take masteral about geotechnical engineering and kung kaya pa doctorate. So it will give you a good compensation package. Kapag pinursu nyo yung geotechnical engineering na career, lalo sa abroad, malaki yung sweldo pag geotechnical engineers ka. Kasi bibihira lang yung mga geotechnical engineers sa buong mundo. So this is one of the specializations sa under civil engineering. Okay, so let's discuss about soil relationships and classification. So soil, when we say soil, it is the relatively loose agglomerate of mineral and organic materials and sediments found above the bedrock. So soil is the product of rock. So nanggaling siya sa bato na nadurog. Kaya siya naging soil. Tama ba? Yes. So rocks have very strong internal cohesive and molecular forces which hold the constituent mineral grains together. Okay? Kapag nag-break yung mga mineral na yun, nagiging soil. So mostly naman, lahat naman siguro kayo familiar na kayo sa soil and rocks. Okay? Then we have the weathering is the geological process that produce soil. It's either by chemical and physical. Then in order to classify soil, we use two systems, standard systems. So one, Unified Soil Classification System or the ASTM D2487-93. It's used for virtually all geotechnical engineering work except highway and road construction. Then kung highway and road construction na, ang ginagamit na classification is AASTO M145-87. Okay, so we'll not discuss that in details now. Then we have some variation in particle size and shape, which depends on weathering process. So nag-form yung soil by means of weathering, by sobrang ulan, init, kung nag-snow, o masyadong tubig, masyadong wet. Then by transportation process, either by water, air, and gravity. So kung by water, dinala siya ng agos ng river, mga ganon. Then air naman, pag may mga ashfall, buga yung bulkan, diba, may mga lupa or soil na kasama sa pagbuga ng mga bulkan. Then by means of gravity, yung nag-landslide or yung puso na nahulog from the mountains. And yun, then types of soil produced by weathering and transportation, we have boulders. Yan yung mga malalaking bato. When we say boulders, napakalaki siya, massive. Then we have the gravel. So ang familiar mo sa gravel, sand, buhangin, silt, and clay. Okay, clay, yung mga lagi nang nilalaro. Okay, we have table 3-1, USC definition of particles, size, ranges, and symbols. So, ito yung soil fraction or component. So, dito nakalagay yung mga symbol niya, then size range, kung gaano lang siya kalaki. So, pag boulders or cobbles, so greater than 300 mm. So, ang laki. That is, boulders na pala yun, basta 300 mm. Okay, pag coarse grain sand, 75 mm. So, ito yung percent passing niya. Coarse sand, fine sand, coarse gravel, fine gravel. So, ito yung mga ginagamit na sa construction materials. Then we have the fine grained soils, fine silt clay. So, during sa inyong soil mechanics, ito nagkamali, merong mga laboratory na ginagawa to identify each classification of soils. Okay, so next. So, all soils daw consists of collection gravel with varying spaces between them, which are usually filled with water. So soils are usually cohesionless, cohesive, or organics. So when we say cohesionless, have particles that do not bend to stick together. So mostly composed of sand, maybe some silt. So mga buhangin is an example ng cohesionless soil. So hindi nagdidikit-dikit kasi hindi malagkit. Then we have the cohesive soils. It is characterized by very small particle sizes where surface chemical effects predominate. So they are both sticky and plastic. So it is mostly composed of clays. So mga clays na yuta. Then we have the organic soils. So it is typically spongy, crumbly, and compressible. So they are undesirable for supporting structures. So it's distinguished by a dark brown to black color. So ito siguro yung mga black earth na tinatawag. So pang siya, pang gardening ng mga lupa or pang agriculture ng mga type of soil. So soils contains three components which may be characterized as solid, liquid, and gas. So solid components of soils are weathered rocks and sometimes organic matter. So liquid component of soils almost always water. So often with dissolved matter. So gas component is air. So the volume of water and gas na nasa soil is referred to as the void. So lagi siyang may void kasama ang lupa. So composition of air and water. So we have table 2-2 textural and other characteristic of soils. We have the soil name, grain size, gravel, sand, silt, clays. Ito yung soil name. Then naka-indicate dyan kung ano yung grain size niya, characteristic niya, and the effect of water on engineering behavior, and the effect of grain size distribution and engineering to be engineering behavior. Okay, let's go next. Soil physical and index properties. We have number 1, soil composition. We have the solids, water, and air. Then soil phases. It's dry, fully saturated, and partially saturated. Then we have the analytical presentation of soil for the purpose of defining the physical and index properties of soil. It is more convenient to represent the soil skeleton by a block diagram or phase diagram. So ito yon. Okay. So we have the phase diagram. So ito yung soil skeleton. So example, this is the soil sample. Okay, composed of solids. Ito yung mga solids. Ito yung mga species or yung mga gap between solids composed of voids. So they are usually water or air. Okay. So phase diagram. So usually kung partially saturated daw, so hindi masyadong basa, meron siyang composed of air, water din. Ito yung parts ng solids. Kung fully saturated naman, basang-basa, so marami yung components ng water kumpara sa solids. Okay? Then kung sinasabing dry soil naman, so wala siyang usually water na components or liquid components. It's usually air naman from dry soil. Okay, and let's go to weight volume relationships. So the total volume of soil, so we have its height, width, and the length. So to get the total volume of soil, we have a volume of voids plus volume of soil, or S equals to volume of air plus volume of water plus volume of solids. So this is the volume of voids, this is the volume of air, and the volume of water. Okay, usually this graphical representation of soil properties may encounter nuisance in your higher years. So it will be discussed in details. So when we say V is of A, volume of air, VW, volume of water, VS, volume of solid, VV, and volume of voids. So same with their weight and their mass. So kung ilan yung proportion ng the volume, meron siyang naka-indicate na corresponding weight and mass. Okay. And so this is the total weight ng soil sample. So hindi kasama yung neglect na yung weight ng air and mass ng air. So usually pag sinabing total weight, weight lang ng water and weight ng solids na nandun sa may soil sample. So ganun din sa mass. Okay. So we have the mass, total mass of soil, mass of water, plus mass of solid. And weight, ganun din. Ba't hindi siya sumama dito? Okay. Okay, next, water content or moisture content. So it's the ratio of the weight of water to the weight of solids, or equivalently, so the ratio of the mass of water to the mass of solids. So usually weight of water, the water content ratio is equal to weight of water divided by weight of solids, or mass of water divided by mass of solids. So unit weight is the specific weight or weight density relation of the weight of material to its volume. So the unit weight of water is usually 9.81 km per cubic meter. So for the formula in combination of total unit weight of soil, that is lambda, is equal to weight, total weight, divided by the total volume, or equals to weight ng solid plus weight ng water divided by volume of solid plus volume of water plus volume of air. Sa volume, kasama na yung volume sa air. Okay, then the dry unit weight, get the ratio of the weight of solids to the volume, to the total volume. So YD is equal to wet, dry weight, or WS, so ating dry divided by volume. Okay, then we have some geotechnical structures na consider sa ating as part of civil engineering. We have the number one, foundation is a constructed unit that transfer the load from a superstructure to the ground. So most foundations receive a more or less concentrated load from the structure and transfer this load the soil underneath the foundation, so distributing the load as a stress over a certain area. So we have two types of foundations, shallow foundations and deep foundations. Okay, saan ba ginagamit yung shallow foundation? So it's mostly for firm soils or light loads. It transfers building loads to the earth very near to the surface. So usually sa mga ano lang siya, maliit na structure or sa maliit na mga building. So we have, ito kunyari yung bahay. We have the shallow foundation, that's either square footing. So this is combination footing. We also have rectangular footing, trapezoidal footing, so circular footing. So marami tayong types of shallow foundations. that you will learn how to design under your foundation design subject tutorial sa inyo. Then we have deep foundations, mostly for weak soils or heavy loads. So ito na yung mga malalalim na pundasyon, usually mga pilote or pile, sheet piles. Usually ginagamit na siya ng mga heavy equipment. It's either binabarena or dinidrill or pwede rin yung mga hammer. Parang pinupukpok lang. Hammer na equipment. Usually it makes of high strength ng mga iron pipes. Then lalagyan lang siya ng concrete grout. Okay. Ginagamit niya sa mga matutubig na mga area or kung saan tatay yung structures. So para sa sa mga bridges, so nasa tubig naman siya. Fully saturated yung lupa, so dapat talaga gamitan mo siya ng pile cap. Or kung hindi, ko-collapse yung structure mo. Dapat malalim na malalim kung saan maabot niya yung pinaka-bedrock. Then we have slope protection. So we have the retaining walls. It is used to retain soils from spreading laterally. So ito yung mga examples ng retaining walls. Usually makita nito sa mga rivers or sa mga highways. So ito is example of modular block walls. So ginagamit ito sa highway. Ayan. Kita ko sa mga intersection, sa mga overpass. Kita sa malapit sa Manila and sa, hindi ko sure kung sa Tagum ba to or sa Panabo, paano may ginamit na ganito. Then usually ang retaining walls is made of rocks naman. Pinaka-popular syempre yung riprap and the gabions and goods. Then we have some example of slope protection. We have the soil nailing, steel rods placed into holes drilled into walls and grouted. So ito yun. So may mga steel rods dyan, babaon gamit ng heavy equipment or drilling machines. Babaon sa lupa. Para siyang ang gamit, ang purpose niya is parang pako na kanil sa lupa para hindi bumagsak itong part na to, lupa. Then after which na may baon sa lupa, naano siya ng concrete grout sa loob para hindi siya bumigay. So usually mahal pag magpa-soil nail ka. Napakamahal nito na slope protection. Parang isang ganito pa lang 100,000 na or mga ganun. Kailangan nyo magagawa nito na contractor is expert. So hindi siya basta-basta. So delikado, lalo na kung ang soil mo dito is very weak. Kasi kada galaw mo dyan, ko-collapse. So dapat magaling talaga yung contractor mo nito. Saka designer. Yung nga lang, medyo mahal siya. Expensive. Okay, we have the shotcreting. So it's sprayed concrete through a hose and pneumatically projected at high velocity onto a surface. So ito yun. So usually after nung soil nailing, yung iba sinashotcrete. Para ito yung bundok. May mga wire mesh kalagay or mga reinforcement muna bago i-shotcrete. So usually makikita kayo nito when you are going to Baguio. Merong part doon bago mag-tunnel. Merong mga part ng bundok na naka-shotcrete. Ito is para maiwasan yung landslide or rockfall sa mga bundok. Maganda nga itong gawin dito sa sa mga along badas na roads kung saan maraming mga rockfall. Maganda yun kasi medyo matigas-tigas yung lupa. So sakto siya dito. Kaso rin to, medyo costly rin to. Per square meter, then depende rin yung thickness sa design. Medyo matrabaho rin siya at hindi rin basta-basta ginagawa. So dapat expert lang din ang gumagawa nito ng mga contractor. Actually yung first job ko, ito yung ano ko first naging trabaho ko. Supervisor sa mga ganitong slow protection, shotcrete, soil nailing, and meron pa yung rock anchoring. Ganun, parang rock anchoring halos parehas lang sila sa soil nailing, pero ang rock anchoring naman mas malalalim. Ito medyo mababaw lang to. Then we have the sheet piles. So sheet piles naman is sheets of interlocking steel or timber driven into the ground, forming a continuous sheet. So it's used in excavations, waterfront structures. So if you can see, sa paggagawa ng mga tulay, so yung tulay papalibutan mo na ng sheet piles para hindi mapasukan ng tubig yung loob, makonstruct yung foundation ng tulay. And ginagamit rin siya as to protection para hindi umiga yung lupa, lalo na pag nahamahan ng tubig. So parang ganito, lagyan mo siya ng mga sheet piles palibot. Ito na yung pinakapundasyon ng gagawing tulay So you can notice may mga pump din dyan, tinatapon ng tubig palabas kung sakaling malagyan siya ng tubig sa loob. Yan. Ito na yung pinakapundasyon ng gagawing tulay. Okay. So ganun ka busisi. So ang galing. Then of course, support din siya lalo sa mga river or sa floods. Okay. Then we have the dams. It is used for impounding water. So we have earth dams. There are many types of dams actually. So ito lang muna ng dalawa ang discuss ko. We have the earth dams. It's embankment dam built by compacting successive layers of earth. So usually ito yun. Sample nyo. Merong lupa sa gitna yung pinakaloob. Inalagyan lang siya ng mga sand paikot. Sand, gravel, then stones. So pinapile siya ng maayos. Then blocks or mga boulders. So dapat dito maganda yung pagkakapile mo para hindi to magos yung tubig sa loob. Kasi kung nag-sip siya doon sa loob, sira yung earth dam mo. So usually ginagamit sa mga hindi mababaw lang na dam for agricultural purposes. Okay. Then we have the concrete dams. A gravity dams usually built in large blocks divided by joints to make construction more convenient and reduce thermal stress. So ito yung example ng mga concrete dams na ginagamit for hydraulic structures. So for hydraulic energy or energy purposes. Then we have tunnels. It's underground passageway dug through the surrounding soil or earth rock and enclosed except for entrance and exit commonly at each end. So I'm sure familiar mo sa mga tunnels. Ito yung mga para sa subways o dinadaanan ng mga tren sa ilalim ng lupa. Lalo yung ginagawa ngayon na subway project sa Metro Manila. So for the first time in history, magkakaroon tayo ng subway. Kasi grabe ng congested ang traffic sa Manila. I'm sure maging matibay kasi Japanese yung contractor gagawa. Okay, we have the geosynthetics. It's known as geotextiles, geogrids, and geomembranes. It's used to increase the safety factor, improve performance, and reduce costs in conventional construction alternatives. Ito yung mga example ng mga geosynthetics. We have the geofiber. Ito yun. Ilatag mo na siya sa lupa. Then ito, lalagyan siya ulit ng lupa. Parang ganito. Yan, para ma-avoid yung mga landslide or pagdulas ng mga lupa pupuntang sa bottom. So, ito yung mga geosynthetics. Usually, pwede rin ito mga bato or concrete para mas tumibay yung structure. So, gamitin siya para sa mga slope protection. Okay. So, yun lang muna ang discuss ko. So, hindi ko na-discuss na haba. And it's not discuss in more details. Okay? And for your next activity, so group activity ulit. So you will conduct soil testing. So you will need to prepare the following materials or food. Okay, what you need to do, so punta kayo sa likod bahay ninyo and measure a 1.5 by 1.5 square. So parang ganito, gagawa kayo ng square. Sukat niyan is 1.5 by 1.5. Okay, okay, yan. So square siya sa inyong likod bahay, dapat safe yan. Then after which, dig a hole at a depth of at least 1 meters. So ito yung plan view niya. That is 1.5 by 1.5 meters. Hirap magsulat. Okay, then dig a hole daw. So ito yung section. Section. So ito yung 1 meters. Then magbangag mo og hole. Ito yung gisunukat ng 1 by 1 meter, no? So pangakan nyo siya og at least 1 meters. Kalawang daw. So ito yung ground. Okay.
Ay, sa template siguro ni Ona.
Okay, so dapat ganyan. So that is depth of 1 meters, at least 1 meter daw. Okay. Then kung na bottom dire, admission mo ng 0.3 by 0.3 square. So let's set color red. So ito 0.3 by 0.3. Wait lang.
May mga template nga dili.
So that is 0.3 by 0.3. Okay, then ito yung example na 0.3 by 0.3. Then trim the outer part. So ito yung outer part. Paikot siya. So kung sa top view, so ito yung 0.3. Ito na yung bottom na. So square gapon siya pala. 0.3 by 0.3. Okay, in the top view or plan. Then ito, yan.
Control A na lang to.
Then i-trim nyo yung gilid. Trim nyo daw itong paikot. Of at least 0.2 meters deep. 0.2 meters. So yan, buwas nyo ng 0.2. Yan. 0.2. Okay. So dapat maging ganyan ang itsura. Oh, mahirap. Okay. So itong to dapat 0.2 to kalalim, ha. 0.2. And then using the knife or bolo, cut the bottom square. So i-cut the to ninyo. Cut this using the bolo. Cut. Then get the soil sample. So do not touch. Huwag nyo hawakan itong sample na to. Or then hands. So dapat nakasuot yung yung disposable gloves, and after which pagka-cut ninyo, kuhain nyo agad yung plastic para i-cover siya. Cover it with plastic for extracting the sample, not the ground. Then and cut the soil sample to form a 3 by 3 by 6 inches soil sample. So ito na yung soil sample. So ito yung cross-section view. I-cut down siya into 3 by 3. So usually makakuha mo o 4 by 2 sample. So ito yung section niya. Then kung sa plan view or sa top view, ganito yung itsura mo sa top. Apat. So essentially hindi square, hindi straight. Yan. So, apat na sample. 3 by 3 by 6. So, dapat ito ay ang iyahang height is 6 inches. Then, ito ay 3 inches by 3 inches. So, kada square, 3 by 3. 3 by 3, 3 by 3, 3 by 3, 3 by 3. Tapos, ang kalalim niya ay 6 inches dapat. Dapat walang mga cracks. Iwasan nyo na mag-crack or ma-damage yung soil sample. And after which, maging ganito na yan. Makukuha nyo. Maging separate. Sorry. Hindi perfect pagka-drawing. Parang ganyan. So, 3 by 3 sa 6 inches height. Okay. Then, weigh each sample using the weighing scale and record its weight. So, timbangin nyo siya kada sample. Sample 1 to 6. So, at least 6 lang nasa sorry, samples yung kailangan nyo i-prepare. Then, yung tatlong sample, phase 1, sample 1, 2, and 3. Lagyan nyo siya, balutin nyo siya ng plastic. Dapat nakabalot siya ng plastic, ha? Para hindi mawala yung moisture content niya. Then, ilagay nyo sa loob ng refrigerator or rep. Huwag sa freezer. Sa rep lang. Ng naka-plastic. Para ma-preserve yung kanyang moisture content. Then, yung sample 5, 6, 4, 5, 6. So, ibilad nyo siya sa araw. Sa loob ng 2 araw. Sa loob ng 2 days. So, pagkahapon, hipuson ninyo ang soil samples. So, ilagay nyo siya sa cool, dry place. So, dapat hindi siya mababasa o hindi maulanan. Okay? Yung sample 4, 5, 6. Yung sample 1, 2, 3 sa loob ng rep sa loob ng 2 araw. So, after 2 days, weigh sample 4 to 6 and record its weight. Yun yung tinatawag na dry weight or nauga na, uga na weight niya. Okay, and then for the testing, so you need to prepare at least 6 hollow blocks. Then, kuha ng timbang sa each hollow blocks. So, arrange sample 1, 2, 3. So, yung ano daw siya. So, naka-arrange. Okay, wait lang. So, sample 1, sample 2. Basta ganyan lang imagine nyo na perfect yung samples. Then, sample 4, sample 5, then sample 6. Dapat sa table, flat surface, levelado. Okay, weigh each hollow blocks and record its weight. Then put the hollow blocks above its soil sample. So, ipatong nyo ang kada hollow block sa ibabaw sa tulo. So, naadira ang tulo. Itungtong nyo ang each hollow blocks. So, draw a group of soil samples. Okay. So, kung sa loob sa ikaminuto, 1 minute, walay nahitabo, magdungog na po mo additional hollow blocks. Okay, ito yung mga, let's say, dry. Yung sample. Ito yung wet samples. Kung wala nahitabo, buo pa rin siya. So, butang gyapon mo additional hollow blocks. Then, kung wala gyapon, after 1 minute, butang na po din yung additional hollow blocks. Until the soil sample fails. So, kung mag-fail, so ibig sabot ng naana yung mga crop. So, ganito ang tsura nyo, ha. Yan talaga mag-drawing. 3. Okay. Tapos, tangtang ng hollow blocks. Pahigda, ilipat hindot. Pahigda. Okay, then kapag nag-collapse na, use the use the format to record your data. So we have yung sample 1, 2, 3, 4, 5, 6. Yung weight niya, ito yung press para pagkakuha niya sa ano. And the volume, we have 3 by 3 inches, 0.75, 0.75 times 0.15 meters. Dapat pala ito, ano to, meters. Then the weight dry, timbangin nyo after 2 days. Then the weight of the solid, then compute nyo ang moisture content and the load capacity. Ito yung mga weight ng mga hollow blocks na inilagay nyo kada sample. So usually kung sample 1 to 3, pare-pare siya ng load capacity. Ito yung weight ng hollow blocks 1. Kung hindi pa siya nag-fail, then another hollow blocks 2. Hindi pa rin siya nag-fail. Hollow blocks 3 kung gano'n siya kabigat. Then 4, 5, and so on. Kung ano yung kaya niyang i-carry na load or i-carry na hollow block. Kung gano'ng kabigat yung hollow blocks na dinala niya bago siya nag-fail or nag-crack. Okay? Then, submit nyo sa akin yung in a Word format nalagay itong data ninyo kasama yung part C, part D. Your learning and problem solving activities, then attach some photos during the activities. Okay, so if you have questions, so leave it in the comment section. And see you again next meeting. So good luck with your activity. So after nyo makapaghukay, so yung hinukay nyo, kung kaya nang ibalik ng lupa or pwede siyang gamitin as compost pit, tambakan ng basura. So kung hindi gagamitin as compost pit or tambakan ng basura, balik mo lang yung lupa na hinukay nyo para walang disgrasya. Okay, so good luck with that. So hopefully magawa nyo siya agad kasi medyo mahaba siyang proseso. Okay, so see you next meeting. So met natin peace next meeting. Okay, good luck and have a good day. Ciao.